One area that the auditor needs to be familiar with is the tool of encryption. Encryption is the process of converting a message into a format that could not be understood by unauthorized parties. This is done by taking that plain text or clear text of the message and converting it into ciphertext or a cryptogram, usually using something we call an algorithm, a mathematical function. The benefits of encryption are fivefold. 1. It protects the confidentiality of the message which has been stored or transmitted. It also can be used to protect the integrity of the message. We can use encryption to prove authentication. Authentication that that message came from that person, or that that is the person we're talking to. Authentication of either the sender and or the receiver. It also allows us to establish that non-refutable link that says this message is associated with that person. This action is associated with that person. And this is something we call then non-repudiation. Non-repudiation means a person cannot repudiate or deny that they placed that order or sent that email, for example. We use encryption a lot in supporting things like access control. We use things like password hashes and so on, and use it then to ensure that only authorized people have access to our data or to our systems. We use this to protect data both when it's in transit and when it's being stored. In transit, we can often use it for things like transport layer security or its predecessor, secure socket layer, SSL. We also use it at the network layer for IP or Internet Protocol security, often known as IPsec for short. We use it when we're talking with wireless, with Wi-Fi Protected Access version 2. We also protect stored data by encrypting backups, for example, by encrypting a hard drive, and ensuring that even if that hard drive was to be lost or stolen, someone is not going to be able to recover the data that's stored on it. We use this on USB sticks and so on as well. The difficult thing of encryption is understanding all of the terminology. The terminology is really, we can say here, the stumbling block for many people is remembering what is associated with what. A message in its normal format, unaltered, easily readable by people, would be considered to be in plain text or clear text. Then we can feed that plain text or clear text message into a crypto system. The crypto system is the mechanism or tool that is going to be used to convert that plain text into ciphertext, or sometimes called a cryptogram. Crypto systems have varied in many ways over the years. Going back several thousand years, we have examples of crypto systems which are simply a manual process, doing substitution and transposition, using things like disks, using things like the Spartan SkyTel, using other forms, you say here, of manual process to actually then convert plain text to ciphertext. But then came the development of mechanical tools and finally electromechanical tools and computers as we use today. The principles of encryption are still the same. The algorithms merely do substitution and transposition of letters, and substitution means that we then substitute or replace one value with another. Many of you do this when you, for example, choose a password. You might substitute a 3 for an E, for example. The other process is the process of mixing up the position of the letters. It's the same letters, just in a different order, and this is something we will then call transposition. And many of our systems today are simply then, well, computer programs that are doing substitution and transposition. We have two main types of algorithms we use. We have what we call symmetric algorithms, also known as same key, single key, shared key, session key algorithms. And we have then, of course, examples of that through the advanced encryption standard, the old, but of course now replaced data encryption standard, and other tools such as Reversed Cipher 5 or RC5. There's many others, Mars, Serpent, IDEA, Safer, CAST. There's been many different symmetric algorithms developed over the years. Then you have the asymmetric algorithms, and there's many fewer of these. The first one was really Diffie-Hellman, and Diffie-Hellman gave the basis for the development of other algorithms such as Rivest-Shamir-Adleman, then RSA, as well as elliptic curve cryptography and others such as we've seen then the development then of LGML, for example. The secret to being able to make encryption work is the protection of the key. The key is what turns the motor on, if you want to call it that. Now, the key is also quite often called then the crypto variable. We can all use the same algorithm. We can all use the advanced encryption standard. However, we will all choose different keys, and therefore it'll be impossible for somebody else to be able to read the messages you have encrypted unless they know the correct key.